In this video, we are looking at our last section, which is section 2.4. We're going to look in more depth on our solving linear equations. So step-by-step procedure for solving linear equations when we have one variable. First, we're going to remove parentheses. That means we're going to need to distribute what's outside of parentheses. Second, we're going to simplify the expression by combining like terms. And so is there anything that can be combined on the left-hand side together or on the right-hand side together? And then we get to start moving. We'll apply the addition property of equality to move everything that has a variable x on one side and everything that does not have an x or the constants to the other side. And then for step 4, if we have a coefficient or a number in front of our x, then we need to apply that multiplication property of equality to remove it so we have only one x instead of a fraction or a number in front of it. And then our optional step at the end is to plug in their answer into the original problem to see if we get a true statement. Let's take a look at some examples. Example 1 gives us a problem where we do not have any parentheses, so we don't need to worry about step 1. The second step was to simplify, so we have like terms to combine. And so remember, here's your equal sign. When we're looking at combining like terms, we're not looking at doing opposites yet. Because if I think of subtracting 9x here to get rid of the 9x, and move it to the negative 3x, notice what I just did. I put negative 9x twice on one side and nothing over on this side. So that means I improperly combine like terms. And so we can't do it that way. So what we need to do it by is just thinking of ignoring the equal sign and combining what we have. And so we see negative 3 plus 9 for our x. And negative 3 plus 9 is 6. So that'll leave us with 6x there. And then add 30. And then that equals 12x minus 8. So there's nothing else to simplify besides combining those two x's there. And now that we have only two terms on either side, we can go ahead and now start doing the opposites, moving the x's one way and the constants the other. So to isolate the x terms by itself, I like to move the smallest amount of x's to the larger. And so 6 is smaller than 12, so I'm going to get rid of 6x on the left by subtracting it off, because 6 minus 6 is 0. I have no x terms left on that side. All I have is that positive 30 to bring down. And on the right-hand side, 12 minus 6 gives us a coefficient of 6 for our x. And then our subtract 18 just gets brought down. So far we have 30 equals 6x minus 18. So now that all the x's are on the right-hand side, we'll move the constant from the right to the left. We see on the right a subtraction of 18, so we're going to do the opposite and add 18. So that'll zero out, which means across the equal sign we have to add 18 to both sides. So we'll add 18 there, and that gives us 48. Equals, we'll bring down our 6x, and then negative 18 plus 18 zeroed out. So then that final step before we can check it if we want to is to look and see if there's a number in front of x. Yes, we have a coefficient of 6. We need to get rid of that multiplying by 6 by dividing it off. So we're going to divide both sides by 6. And we're left with 8 on the right when we do 48 divided by 6. 6 divided by 6 is 1. So we have 1x, or just x, equaling 8. Let's take a look at another problem. Here we have parentheses on 3 different places. So we need to do distribution 3 different times. So we're going to distribute the 2 first, 2 times x and 2 times negative 4. That leaves us 2x minus 8. In the second set, notice we just have a subtraction there. So we can think of distributing that minus, or I think of distributing a -1, multiplying everything by -1. That would leave us -3x and -1. And then we'll copy our equals sign, bring down your 6. Remember, order's operation tells us we cannot add those two together and distribute 8. The 6 gets brought down. And then we will look at distributing this +2 into our parentheses. So that will leave us plus 2x and -4. Now that we have that done, again, we will combine like terms. So we have our 2x and our -3x as like terms. 2 minus 3 is -1, so we have a -1x. When working through my problem, I like to put that 1. It's not necessary. You could have just written -x if you wanted to. Here we have -8 and -1, or -8 and -1 as like terms. So if we combine them together, we get -9. And that is equal to, on the right-hand side, we only have two like terms. Our constants is 6 and -4, or -4. 6 minus 4 leaves us 2. So 2, and then we'll bring down our plus 2x. So now we have everything simplified as much as we can on the left-hand side and on the right-hand side. Now we'll start moving. When I look at my x's, negative is always smaller than a positive, so we'll change -1x to add 1x, so we'll zero those out. So we have to put plus 1x over here. -1 plus 1 zeros out. We'll bring down our -9. Don't forget that sign there. So subtract 9, or -9, is equal to, bring down our 2, and then combine 2x plus 1x to give us 3x. Now, our x values are all on the right-hand side. We need to move that constant to the left now of the 2. It's positive, so we'll make it negative, or subtract 2 from both sides. -9 minus 2 more gives us -11. 2 minus 2 zeros out there, and we'll bring down our positive 3x. So our last step now is to get rid of that coefficient of 3. Then multiply by 3, change this to divide by 3 so we can cancel. So we divide -11 by 3 as well, which can't be simplified. So -11 thirds is equal to our x. Let's take a look at a couple more problems. Here we have two sets of parentheses that we need to get rid of by distributing. Let's take our 3 and distribute it into our parentheses. So that leaves us 3x minus 6 when we distribute there. Here again we have a minus sign, so we'll think of distributing a -1. So that'll give us -1x plus 5. Common mistake there, a negative times negative is a positive, so don't forget to change your sign. And then we could combine like terms over here, but I'm just going to copy it down and save that for the next step, since I still have like terms on the left to simplify. So for like terms, we have two x terms, 3 and -1, combined together to get 2. So we have 2x, and then -6 plus 5 is -1. And on the right-hand side, we have our 9x minus our 4x to leave us with 5x. And then we'll bring down our plus 1. So now everything is as simplified as it can on both sides of the equal sign. So now we can start moving things around. 2x is smaller than 5x, so that's what I like to take care of first. So let's subtract 2x from both sides. And we're left with -1 on the right, or sorry, the left. And then 5 minus 2 gives us a coefficient of 3 for our x. And then we'll bring down our plus 1. Now that we've taken care of moving our x's, let's take care of moving our constants. We have a plus 1 here that we need to remove. So we'll do the opposite, or subtract 1. So we subtract 1 from both sides. and we get -2 on the left-hand side. Our 3x drops down on the right, and our 1 zeroed out. So our final step is just to get rid of that 3, our coefficient, so we'll divide it off to give us a single x there, and when we divide the left-hand side by 3 as well, we get -2/3 there, equaling our x. Let's do one more similar problem before we look at something a little different. So here we have two sets of parentheses again that we need to get rid of, one on the left-hand side and one on the right-hand side. So we'll take care of those first. And so let's distribute our 4 into our parentheses. Gives us 8x plus 4. We'll drop down our -29. And on the right-hand side, we'll distribute our 3 into our parentheses. And that'll give us 6x minus 15. We have like terms to combine on the left-hand side. So when we combine those, we'll get -25. So 8x minus 25 is equal to 6x minus 15. There was nothing to simplify so far on the right. So now that everything's as simplified as we can get it, let's go ahead and shuffle things around. Let's move our x's to the left. And so we'll subtract 6x from both sides. And that'll zero out there. If you want to, remember, you can go ahead and show two steps at once if you would like, which means since I zeroed out the x's and moved them to the left, let's zero out our constants on the right-hand side and make both sides a plus 25 as well. It just saves some room for our work. So we're zeroing out our constants at the same time as we're zeroing out the x's on one side and then the other. So now if we simplify, we're left with 2x on the left when we do 8 minus 6 for coefficients. And here we have -15 plus 25, which will leave us 10. So it just saves writing a step. Well, save space. We're still writing the same amount of steps. We're just doing 2 at once. And so now we need to get rid of our 2 in front of our x. So we'll divide it off and divide off 2 on the other side as well. Will leave us with x equals 5. So sometimes when we're dealing with problems, we will be given fractions in the problem. And to make them easier to solve when they have fractions, we can get rid of fractions. We can clear them out by multiplying the LCD to both sides. Remember, as long as we do the same thing to both sides, we're keeping the scales balanced. So instead of getting a least common denominator in fractions, if we multiply by what would be the least common denominator, then we will be able to work with whole numbers instead of fractions. And it just simplifies things a little bit more for us, makes it easier to do the math, I think. And so our first example is 3/4 x minus 2 is equal to 2/3 x plus 5/2. So when we're looking at that least common denominator, we need to look at all three denominators, 4, 3, and 2. The smallest number that they all go into is 12. So the LCD is 12. So the entire equation gets multiplied by 12. So each piece gets multiplied by 12. So 12 is going to get multiplied by the 3/4 x. And 12 is going to get multiplied by the 2. Even though the 2 is not in fraction form, we still have to multiply everything by 12 or we're not keeping it equal. So on the right-hand side, 12 has to get multiplied to the 2/3 x. And the 5/2. So instead of writing it on one side with parentheses to distribute that way, I like to write it next to each individual piece because then it helps me with my math. And I'll show you what I mean in just a second by that. So again, 12 got distributed to everything, both sides. So all pieces got the 12. And so now I come through and I'm going to put all my 12s that are next to fractions over 1. And then I can start simplifying. We're going to do 12 times 3/4. And what I do is just say 4 goes into 12 3 times. You're always going to be able to divide because that's why we picked the number 12. And then we're left with 3 times 3, because again, that 4 disappeared. Now we divided it, and technically 4 divided by 4 became 1. And anything over 1, we don't have to write the denominator. So we're left with 3 times 3 for 9 as our coefficient of x. Minus 12 times 2 is 24. That is equal to, let's do the same thing here, 3 goes into 12 4 times. So now we have 4 times 2x to have 8x there. And 2 goes into 12 6 times. So 6 times 5 is 30. So we renamed or rewrote our problem with all those fractions as 9x minus 24 is equal to 8x plus 30. Makes it a lot easier to handle. You could still do your combining like terms and all that kind of stuff with fractions, but then you would have to worry about getting a common denominator and dividing by fractions and all that stuff, where this makes it much easier. So now we have things simplified. We can subtract 8x from both sides. Zero out the x's on the left, or sorry, on the right, move them left. So let's zero out the 24 at the same time to move all our constants right. So minus 24 plus 24 gives us 0. So plus 24 here, that's 4, plus 24. And when we simplify, 9 minus 8 is a single x, so we don't have a coefficient to divide off. And 30 plus 24 will leave us 54. So again, if we plugged 54 in as x, we should get a true statement. Let's take a look at another one. For b, we have 3x plus 1 over 2 equals 1/4 x minus 7/6. So notice 3x plus 1 is all a numerator. I'm going to put those together with parentheses to remind myself that that's all together as one numerator. And then if we look at 2, 4, and 6, we have a common denominator of 12 again. So that means every piece, we have 1, 2, 3 pieces, 3 terms get multiplied by 12. So the 7/6 gets multiplied by 12. The 1/4 x gets multiplied by 12. I'm going to stick it up front right here. And then the 3x plus 1 over 2 gets multiplied by 12. So instead of rewriting everything, that's how I do it. I just kind of squeeze it into my problem and work from there. So this is over 1, this is over 1, and this is over 1. So when I'm going to start simplifying, 2 can go into 12 6 times. Then it's not just 6 times 3x. It's 6 times that whole numerator, which was 3x plus 1. So that parentheses reminded me that I have to take that 6 to both of those pieces, or get 18x plus 6 when I distribute. So that'll be on my left-hand side. And on the right-hand side, 4 goes into 12 3 times. So 3 times 1 is 3. So we have 3x there. And 6 goes into 12 2 times. And so 7 times 2 is 14. So we're subtracting 14 there. So again, that crazy thing, when we multiply by 12, we get 18x plus 6 is equal to 3x minus 14. A little bit easier to work with, I would believe, and I think you would agree. So let's start moving things now that everything's simplified. Let's subtract 3x from both sides. So since I zeroed my x's on my right, let's go ahead and zero our constants on the left. So we see plus 6, so we'll subtract 6, and we'll subtract 6 on the right as well. 18x minus 3x leaves us with 15x. And then minus 14 or negative 14 minus 6 more leaves us negative 20. And so we still have a coefficient of x we have to divide off of 15. So we get x equals negative 20 15ths. They're both multiples of 5. So negative 20 divided by 5 is negative 4. And 15 divided by 5 is 3. So we have x equals negative 4/3 for that answer. So not only will you deal with fractions sometimes in your problems, but you will deal with decimals. And since you're using the calculator to help you sometimes, I think that some problems it's easier just to leave the decimals alone, and some it's just as easy to remove them. But you can, remember, multiply both sides by the same thing to get x by itself easier. So same thing with decimals. If we multiply by units of 10 or multiples of 10, we can move those decimals, because remember, multiplying by 10 just scoots that decimal over once. Multiplying by 100 would scoot that decimal over twice, and so on. So if we look at our problem here, the most amount of decimal places we have is 2. So 2 decimal places, 2 zeros, means if we multiply everything by 100, we can get rid of those decimals, which means we're multiplying by moving the decimal 2 spaces. So we're going to get negative 110x there, minus moving the decimal 2 spaces, or multiplying by 100 leaves us 425, is equal to, moving that decimal 2 spaces will give us 140x, and then moving those decimal places 2 times will leave us minus 150. So multiplying everything here by 100 got rid of those decimals. And so it's up to you whether you think dealing with the decimals is easier or dealing with these larger numbers is easier. That's up to you. You don't have to solve it by getting rid of the decimals. You can just deal with them as they come. But when we remove them, we're still going to solve it the same way. We have a negative 110x. I'm going to add that because I get rid of my negatives whenever possible. So I have to add 110x to the side. So 0 out. I'm just going to do them in 2 steps. Negative 425 is equal to 250x. There. And we can't forget to bring down our minus 150. So that means we're going to have to add 150 to both sides. So our x term is by itself. And when we simplify here, we will get 575 is equal to 250x. And so our coefficient to divide off of is 250. So we'll divide that on both sides. And since our problem had decimals, it makes sense to leave our answer as a decimal. So if we divide, we will, oh, I added wrong, didn't I? Because I combined like they were the same sign, and they are not. They are opposite signs. So let me fix that. Sorry, I'm not perfect either. And so negative 425 plus 150 would leave us negative 275. So then when we divide negative 275 by 250, we get negative 1.1. And so that is equal to our x. Let's do one more. And this example is the reason why sometimes I don't like changing the decimals, because notice we have a parentheses here, and what's being done on the outside of parentheses, the 0.6 multiplying gets distributed. So when I move decimals, I don't move them inside the parentheses, because then I'm moving them once for out here and then distributing it, and if I moved them in here, those get moved twice instead of just once. And so if you're going to take care of the moving decimals, you cannot do it inside parentheses for this problem, because then when you multiply, it'll get distributed and then they will get those. And so if we're doing this to get rid of decimals, just to show you how it would be done, again, I see 2 spaces being the most amount of decimals, so multiplying by 100 would move those decimals 2 spaces. Again, I can't use it inside the parentheses right now, so I would have to add 0 when I can't move 2 spaces, so I'm left with 60 here. And I still have a decimal of 1.5, but that'll get taken care of when I distribute. If it doesn't, then I can go ahead and multiply again to get rid of that. As you can start to tell, I think sometimes it's just easier to do the math with the decimal than to move it. That's just personal preference. So multiplying what's not in parentheses by 100 gives me 60 times 2x plus 5 is equal to 70x minus 235. So now when I distribute, I'm going to get 120x plus 90, so now it's not in a decimal anymore, is equal to 70x minus 235. And now that we have everything as simple as it can go on both sides, let's get rid of our 70x. So we're going to subtract 70x from both sides. And I'm going to zero those out. So let's zero out our 90 to move our constants to the right. So we're subtracting 90 from both sides. And 120 minus 70 leaves us 50. So we have 50x on that side. And we have negative 235 minus 90 more, which will give us a negative 325. So we need to get rid of our coefficient of 50. So 50 divided by 50 leaves us 1x. And then negative 325 divided by 50 will give us negative 6.5 or 6.5 in decimal form. We have one more idea to conquer before we're finished with this lesson. So far, each linear equation that we have had has one single solution. Sometimes that's not true. Sometimes when we're trying to solve an equation, we're going to get an equation that doesn't make sense. We're going to get something that's a false statement, like 2 equals 9, which never can happen. And sometimes we'll get the same thing on both sides, such as 7 equals 7. I'm sorry. So what we've been dealing with are called consistent or conditional equations, because the answer is conditional on only one value. So x equals 23. 23 would be the only solution, or the unique solution, that would give you a true statement. When we have something that gives us a false statement, like negative 5 equals 0, that is considered an inconsistent equation. They have no solution, because no matter what number you try and plug in, you will not get a true statement. So no solution. The easiest way to write that is just your 0 with your line through it. However, sometimes you get an identity equation where you have the same thing happening on both sides. And so you'll get a true statement. So no matter what you plug in for x, it's going to work out for you. And so you're going to have an infinite number of solutions, which means you have all real numbers. And I think I showed you that at the beginning of the semester, that symbol for all real numbers, or you can say infinite solutions. So another way you can use the infinity sign, infinite solutions. Let's take a look at a couple examples that show those two different ways that we can get an answer when it doesn't come out to just one specific number. And so for this example, we're going to start solving it just like we would any other, which means we need to start off with distributing. So we'll get 3x minus 3 there. Bring down our plus 9. And again, I'm just going to copy that right-hand side for now. 8x plus 6 minus 5x. Combine like terms here. We'll get 3x plus 6. And here, 8 minus 5 is 3, so we'll get 3x plus 6 as well. So notice that both sides are the same. So that means we're going to get all real numbers. If we continue working it out, let's say we wanted to move all our x's over to one side, we would subtract 3x from both sides. And when we want to simplify that, we would zero out both x's because 3x minus 3x is 0 for both sides. And then we're left with the true statement of 6 equals 6. And even if we went further down the line, we could subtract 6 from both sides. And we can get down to 0 equals 0, which any solution that has all real numbers can solve down to 0 equals 0. But as long as you stop with the left-hand side equaling the right-hand side, you could have stopped at 3x plus 6 equals 3x plus 6. Once both sides are equal, they match perfectly, then your solution is all real numbers. And let's look at this example. We have a 3 to distribute. Notice there's a minus, so we have to distribute the negative 3 there. So we'll drop down our 5x. And we'll get negative 3x minus 3 there. And that equals, let's distribute our 2, and we'll get 2x plus 6 minus 5. Combining like terms, 5x minus 3x will leave us 2x minus 3 is equal to 2x plus 1. So here I have 2x subtracting 3 is the same value as 2x plus 1. That can't happen because 2x and 2x match, but negative 3 and positive 1 don't match. And so that's going to be a no solution. And if we try and simplify it any further, when we go to remove our variables, again, they're going to zero out on both sides. But instead of having the same number equaling itself, we're going to have negative 3 is equal to 1. And negative 3 never equals 1. It doesn't equal. So our answer is no solution. Nope. Just trying to undo that to circle that. So no solution. So again, you can just use that symbol instead of writing the words. So those are examples of when you would get all solutions or no solutions for your answer. Now it's time for you to practice. Practice problems from 2.4 on pages 63 and 64. So as you work through those, if you have any questions, don't hesitate to send me an email and I'd be happy to explain them. Otherwise, oh, that says 2.3 instead of 2.4. Anyway, otherwise, you're getting close to the end and I'll see you for the finals.